in PA6, we'll extend PA5 a little further. Now think back. What PA5 does is to do this, file upload and one at a time, although it's in already an infinite loop. Okay, so we need to take one request, upload the entire file, and then take the second request, upload the entire file. So this service model is called the sequential service model. Okay, if you think about it further, for the second request, it needs to wait for the entire file upload for the first request to complete in order to begin. Consider the scenario where the file upload time is super long, a video file, for example. And if we have a lot of these requests coming in within a short range of time, then those who come in slightly later than the others, they will have to wait until all these video file uploads complete before it gets served. So those wait time could be sometimes unbearably long. Okay. This is also why when you go to certain web services, and it seems to take you forever to get the server to respond at all. Chances high that the server is also implementing the service in a sequential way. Not a very good user experience, is it? So we'll try to exploit a special functionality in Golang called the Go routine, and I'll explain right now. And the Go routine works this way. In your program, you can specify a block of code that runs in this concurrent execution mode. Right? So to be exact, you start the program, and it's going to start from the first line and on and on and on. As soon as it hits the code block being concurrent, the process is going to be forked out, okay, of the main process, creating a child process. And that process is going to, starting from the first line of the code and execute till the end of the block. The main process here will actually skip the entire block and starting from the next line out of the block and continue execution. So the main process and the child process will be seemingly running in parallel. Okay, but to be exact, it's more just concurrent processing, not parallel processing. When we say parallel processing, we actually meant more that there are two CPUs and the two processes are running on two different CPUs. So at any given point in time, you do have some computation cycles, multiple computation cycles that can do the work for multiple processes. Here in Golang, you have two processes. They seem to be working simultaneously, but they are actually taking one time size at the time of the CPU, okay, and iterating like this. So it's not exactly parallel execution. Instead, we call this concurrent execution. And that is the magic we want to exploit implementing our file upload server. And the way we'll be exploiting Go routine is this. Provided your file upload server code, right? So you sit there and wait for a request to come in. As soon as there's a request coming in, fork out the child process, allowing the file upload going here, while the main server process will skip the file upload part and back. Now, your server in PA5 is already what? A looping server, right? So it's gonna go what? Back to wait for the next request. And as soon as it hit that there's a request coming in, you'll fork out yet another process, and the main process go back to listen to the third request. Third request's upload is going to be what? Yet another separate process. The main process is going to come back for the yet another request. So you see, every upload request will be what? Addressed quickly, okay? But the uploading will continue on over time. But each client will actually receive some initial feedback saying, hey, the uploading started. All right, so your users will be slightly happier seeing that, okay, I'm actually being handled. It just takes time, okay, to complete. And by exploiting Go routine this way, we managed to allow file upload requests being started earlier before all the previous file uploads are complete. Be careful though, the entire completion time is going to be the same because there's only one CPU that we're running the processes on. Okay, so if it takes 100 cycles to upload the file, it will remain taking 100 cycles to upload the file. All right. The only difference is that the starting time of these file upload will be slightly earlier. Okay. So in a way, using concurrent execution is a way to exploit customer psychology a little bit so that we invest the same amount of money, the system capacity remain the same, while we get slightly better user experience. Right? So here in PA6, you'll be turning the file upload part of your pa5.go concurrent. Let me repeat, your pa5 specification is this. Listen at the port assigned and wait for an upload request. Read the file size first, and then begin to read the file line by line. Prepend the line count, and output the new line to whatever.txt. Repeat step 3 and 4 until the entire file is exhausted. Send the message back telling what is the original file size and the new file size. Close the connection and go back to step 1. In pa6.go, please make the code block between step 2 and 7 a go routine, and then add a 5-second delay between step 6 and 7 just to create some extra delay and to emulate a little bit of the processing time or file writing into database time.